Welcome back students to my channel. Today we are going to discuss very interesting topic in physics which is types of work done. In last lecture if you remember we discussed what is work done. In physics we say work is said to be done only when the force is applied on a body which makes the body move. That is that there is a displacement of the body from its original position because of that applied force. So simply work, what is the formula? What is the expression for work done? Work is nothing but force into displacement. Fs cos theta. Now what is this theta here? The theta is the angle between the force and displacement. Look here students. What is the expression for work done? Work done is equal to F cos theta into D. So what is W represent here? W is nothing but a work. F is what? Force. And D is what? Displacement. Because we are applying force and the body displaced from its original position, it will move. That displacement is D. And what is theta here? Theta is the angle. Which angle students? Look here in this picture. Theta is the angle between the force and the displacement. Okay, that angle is theta. Now our topic is types of work done. What is our topic? Types of work done. Let's start discussing now types of work done. Let's start with the first case when the theta is equal to 0 degree. What is the meaning of 0 degree? Theta is, I told you, that is the angle between force and displacement. Look here, we are pushing this block with our hand. Okay, that push is nothing but a force. So we are applying force in this direction of the arrow, and body also, this block is also moving in the direction of applied force. The both arrows are same direction. Why? Because the force and displacement, they both are in the same direction. If the both force and displacement, they are in same direction, the angle between them will be 0. And if the angle between force and displacement is 0, what we have angle? What we call that angle? Theta. Theta is equal to 0. So students, what we will get the expression then for work done? Work is equal to force into displacement into cos theta. What is theta? 0. If theta is 0, this cos 0, remember students, this cos 0 value is 1. What is the value of complete cos 0? 1. In trigonometric table, the value of cos 0 is 1. If this whole is equal to 1, then what is the expression for work done? F into D. So this is the first case when theta is 0. What is theta? The angle between force and displacement is 0. The expression for the work done is F into D. So this is called the positive work done. What we call this first case, students? Positive work done. Okay, types of work done, I told you the heading. The first type is positive work done. So what is positive work done, students? Positive work done means when the angle between force and displacement is say 0, or we can say the direction. Look at here, the arrows direction both are same. The direction of force and displacement is same, like the direction in which we are applying the force, the object is also moving in that direction. In that case, the angle between them is 0, and the work done is which type? Positive work done. Let's start discussing the examples of this. What we are doing here, students, there is a ball which is, we are applying force on that ball. In which direction? In the downward direction. In which direction we are applying force, student, here? Downward direction. Why the object is moving towards the downward direction? The ball is going towards downward. The reason is what? The ball is dropping from certain height. Students, we know that when the ball is dropped from certain height, the Y ball moves in downward direction towards the ground because of the gravitational force. Everything attracts towards the center of earth because of the gravitational force. Now force is acting in which direction in this case? Downward direction. And the object is also moving in which direction? Downward direction. Means force direction is also downward and the direction of displacement is also downward. Now if both are moving downward, both directions are same, the angle between them will be what? The angle between them is 0. If the angle between them is 0, what type of work done is it? Positive work done. Okay, because the expression for that is F into D. What is the expression? F into D, because cos 0 is 1. Clear, students, this example? Okay, if it is clear, what is the next example here? Look here. This is also a positive work done. Look now, this is weightlifting. Okay, this boy is applying the force. In which direction, students, he is applying the force? He is applying the force in a upward direction. Okay, to lift the weight, he is applying the force in a upward direction. Now come to the displacement part. Displacement is also in a upward direction, because this during this lifting the weight is also moving up. Okay, the both directions are same. If both directions are same, the angle between force and displacement is again 0, and cos 0 is nothing, students, but it is 1. And if it is 1, what is the expression of work done? Work done is equal to F S cos 0. Cos 0 is 1, so it is F into D, force into displacement. Okay, so this is which type of work done, students? Again, this is the positive work done, because the direction of force and displacement is same. Okay, clear that the first type? Yeah, so next type is what? When the work done is when the angle between the force and displacement is 90 degree, and that type of work done is called as zero work done. Okay, what we call, first is positive work done, next is which type of work done? Zero work done. Now students, there are two cases for zero work done. The first case is either, very easiest one, if we are applying force. Look at here in this picture, it will be clear to you with the example of this in this picture. What they are saying, the person is applying the force on which thing? On a wall. Okay, he is applying the force on wall. But what do you think? Wall will move? No. Answer is no. The wall will not move. So the what will be our displacement? Displacement will be 0. So this is the first case when the work done will be 0. When the displacement will be 0. Why? Because the work done is nothing but force into displacement, Fs cos theta. Now students, if S is 0, then this whole expression will be 0. So in that case, work done will be 0. So this, I think it is clear to you that we are applying force on something, but the object is not changing, it's not displacing from its original position. In that case, the displacement will be 0. And if displacement will be 0, then the work done will be 0. Now come to the another case, when, which is our case number second, which is very important, that what is another way in which the work done will be 0? When the angle between the force and displacement is what, student? It is 90 degree. Look here now, what is that case? We are applying force in a direction perpendicular to the direction of displacement. Look here, in this picture it is clear the direction of force is in which direction? Downward direction. But the displacement is in which direction? In this horizontal way. Now what will be the angle? Angle between force and displacement will be what? It will be 90 degree. Now students, please keep it in mind that cos 90 is nothing but it is 0. If this whole factor will become 0, then 0 multiplied by these two is also 0. So work done will be 0. I hope it is clear that when the angle between force and displacement is what? 90 degree, then in that case the work done will be 0. So there are two cases when the work done will be 0. Either the displacement will be 0, or the angle between the force and displacement is 90 degree. In that case also the work done will be 0. So that is the second type of work done, students. So let's move to this example now. Yeah, that's very interesting example, students. Look here. Now, whenever an object is moving in a circular path, do you know the why the object moves in circular path? There is one force which is responsible for that. What we call that force? Centripetal force. And centripetal force, the direction of centripetal force is always towards the center. Now, the direction of the force is in which direction? Towards the center. Now, displacement is along which displacement in a circular path of direction is clear. Centripetal force is downward as towards center, and displacement always along the tangent. Now angle between these two, the direct angle between which two things? Between the force, centripetal force, and the displacement of the object is 90 degree. And if the angle between them is 90 degree, means theta is 90 degree, cos 90 is 0. In that case also work done will be 0. Means when object is moving in a circular path, the work done will be equal to 0. Why 0? The angle between centripetal force and displacement is 90 degree. Yeah, that's also another beautiful example we have here, that whenever a object is carrying a load on his head, okay, now students, he is applying the force in which direction? Upward direction. Clear, students? But the displacement, he is moving in which direction? Forward direction. Okay, now the angle between both is what? Again it is 90 degree, and cos 90 is what? 0. If cos 90 is 0, work done will be 0. So in this case also, students, when a person is carry a load on his head, what he is doing? Suppose they are saying another example, a coolie, okay, is carrying a load or a suitcase on his head and he is walking. In that case also, students, the force is applied in upward direction, displacement is in the forward direction, angle between both is what? 90 degree. And if the angle between force and displacement is 90 degree, the work done is nothing but 0. So in this case also the work done is 0. Okay, so this is the case, this is the second type of work done, that when the work done is 0. Now let's move to the next, negative work done. Negative work done is the case, students, when the angle between the force and the displacement is what? 180 degree. What is the angle between the force and displacement? It is 180 degree. Students, in this case, why it is negative work done? Because cos 180, the value of cos 180 is nothing but minus 1. Okay, so that's why the work done is negative. I will show you now the example here. What is the example here, students? When we throw a ball in a upward direction, students. So what we are doing? We are applying the force in which direction? Okay, the object is moving in which direction? Upward direction. Okay, if we will talk about here the gravitational force, students. Gravitational force is acting in which direction? Always it is downward. So the force is gravitational force is acting downward. Object is moving, displacement in which direction? Upward. The angle between F and D is what? It is 180 degree. And now the expression of work done will be Fs cos 180, and cos 180 is nothing but minus 1. So it is work done will be what? Negative. So this is the case when work done is negative. Okay, so clear? So this force which we are talking, students, remember that is not that force which we are applying on object. This is we are talking about the gravitational force which always act downward direction, and displacement is in which direction? Upward direction. I hope it is clear. Yeah, another very beautiful example. So it will be clear to you that negative work done with this. Frictional force. Student, frictional force always act opposite to the direction of the motion, because this frictional force is nothing but it is a resistive force which always try to stop the motion of the body, resist the motion of the body. So the frictional force direction, if the object is moving, suppose in this direction, the frictional force will be always opposite. Okay, so the angle between force and displacement is what? 180 degree. If it is 180 degree, students, again the work done will be negative, because cos 180 is nothing but minus 1. So these are the three types of work done which we discussed today. Positive work done. What is, student, positive work done? Positive work done is when the angle between the force and displacement is what, students? 0 degree. Then it is FD. And then we have discussed the zero work done when the angle between them is 90 degree. Okay, between force and displacement is 90 degree. Next is the negative work done when the angle between force and displacement is 180 degree. I hope this is clear to you. If it is clear, students, please don't forget to subscribe my channel. Thank you, everyone.